Alright, so besides the selection, another operator we will show here is called joins. And we can also implement the joins with this index-based algorithm. Let's assume we have two relations, R and S, and we want to compute the joins between them. It really depends on the index available for these two relations. Let's assume if this S relation has an index table on the join attributes, then we can implement this algorithm with this index table on the S. We can do so. If here we also assume this R, we don't have such index. And if so, then we can iterate over all the tuples in the relation R. And for each tuple in the relation R, we can fetch or retrieve the corresponding tuples with the same join attributes values from S based on its index table. Right? And we can iterate all the tuples and fetch the corresponding tuples from S for the joins. And we assume this R is clustered, and if so, then the cost will be about, we have to retrieve all the tuples from R, right? And here we assume R is clustered. It also depends on the index. If this index is also clustered, if so, then the cost will be about BR, because we have to retrieve all the blocks of the relation R, right? Inside we have BS over VSA, right? Which will be about the cost for selection tuples with the value equals to A, we showed before in the previous page. However, here for each tuple in the relation R, we have fetch its corresponding tuples. Therefore, the cost for this step will be TR times this selection cost, right? At the same time, if this index is unclustered, if so, we will have to change BS to TS instead, right? Because we will do the selection of the tuples matching the attributes for each tuple from R in this step. In other words, this cost will be about BR plus TR times TS over VSA. The main difference between the BS and the TS is the same as the previous page we show here, right? Depending on if this index is clustered or unclustered. Okay, so for this case, we assume this S has an index. However, this R doesn't have index, but this R is clustered. Depending on this S index is clustered or not, then we can have different cost. Another case is that we have both R and S, they have a sorted index or clustered index. If so, then we can join another way, right? And we can perform this merge join directly only with these two index tables, right? And the cost will be BR and plus BS, which will be very straightforward, as we showed before, right? Because we just need to retrieve all the blocks from R, and we can fetch all the corresponding tuples, all the blocks from S based on these index tables. The cost will be very low compared with the previous case. So these are the two cases. We can implement joins between R and S based on this index-based algorithm. And you can compare them with the previous one parse, two parse, as well as two parse algorithm with hashings to see the difference in their cost and how to implement them. Okay, so this is a section on the query processing. We have provided you with the introduction for many different algorithms we can use to implementing different operators we use in database systems. With this kind of knowledge, you will be able to do the homework 1 already, and you can also check some of the questions. Then you can check back the materials we cover in the lectures. You may also need to check the textbook as well, because these slides and the lectures can use as a roadmap only. You cannot rely on these lectures as well as slides to do the homeworks, and many of the questions will also appear in the final exam as well. So please spend some time on this and make sure you can understand these materials very well, and also you can understand these algorithms together with the cost. Alright, so that's it for this section, and thanks a lot for your attention. And we'll move to a new section on the query optimization in the next week.